Welcome back to the channel. This is pretty interesting problem, and this is very good for those who are preparing for some entrance examinations like IIT JEE or gaokao or even Olympiad. So the problem is that there is a rope, and that rope has a, let's say, uniform density, and it is resting on two inclined planes, and the friction between rope and the inclined plane is mu, and this is symmetric. The plane makes an angle theta both the sides. So at some moment, this rope will become static and this will just stay as it is. So the question is, what is the length of this hanging part, this part? And what angle maximizes this length? So let's say this length is x. So at what angle theta, the x will be maximum? I would really urge you to give it a try. And if you want to do so, just pause the video and try to solve this problem. Okay, it's not a difficult problem as I said earlier. So let's just draw the free body diagram because it will allow you to write some equations pretty nicely. So, but let's make some assumptions here. So let's say that length of the rope is L, and let's say length which is hanging is X. And now let's draw the free body diagram for the rope which is on the platform. So let's say this is the rope which is on the platform. There is a friction here and a normal force. So let's say this is the normal force. Weight is acting downwards and the friction force is mu n. And let's assume that there is a tension T. What is the length of rope that is on the platform? So length of the rope on platform is L minus X, right? So on each side, it will be L minus X by 2. So that's the length of the rope on the platform, right? Okay, so let's assume that density of the rope is rho. Okay, so this weight that is acting downwards is nothing but rho L minus X by 2 into G. You get that, right? Because the total length on the platform is L minus X by 2. Okay, so let's choose this axis as X and this one as Y. Okay, so we know that fx is 0 because it's not moving. That implies t plus rho L minus X by 2 G and sine theta, because this angle is theta, minus mu n equal to 0. Let's call this 1. We also have Fy equal to 0. That means n minus rho L minus X by 2 G cos theta equal to 0. Let's call this 2. And if we consider the hanging part now, let's say this is the hanging part. So here we have T, this is T, and we have rho xg. Okay, this is theta, right? So this is 90 minus theta. So we have 2t sine theta equal to rho xg. That implies t equal to rho xg by 2 sine theta. Let's call this 3. From 1 and 2, 3. So we'll put t from equation 3 and n from equation 2 into 1. And then what we will get is rho xg by 2 sine theta plus rho L minus X by 2 G sine theta minus mu rho L minus X by 2 G cos theta equal to 0. That implies we can get rid of rho and G everywhere. Okay, as you see. So we'll end up with x plus L minus x sine square theta minus mu L minus x sine theta cos theta equal to 0. Okay, let's just separate the x from the others. So we have 1 plus mu sine theta cos theta minus sine square theta plus L sine square theta minus mu sine theta cos theta equal to 0. X equal to L mu sine theta cos theta minus sine square theta by 1 plus mu sine theta cos theta minus sine square theta. Okay, so let's assume that, let's say f theta is mu sine theta cos theta minus sine square theta. That implies x is L f theta by 1 plus f theta. Okay, so for any given angle and mu, we can say that this is the length that is hanging. Now the question is also asking what is the angle theta which maximizes the hang or x if mu is equal to 1. Okay, so for max x, we can say dx by d theta should be 0. What is dx by d theta? So dx by d theta is simply L 1 plus f theta, f prime theta, and minus L f theta, f prime theta, 1 plus f theta whole square, which is L 1 plus f theta minus f theta, f prime theta by 1 plus f theta whole square. This will cancel out, and this is, we need to put it to 0. So that means when f prime theta is 0, then we get maximum x. Max or minimum you can check by double differentiating it, but for the sake of time, let's assume that this is giving us maximum, which is true also. Now, what is theta? What is f theta? So f theta we already know is mu sine theta cos theta minus sine square theta. So this is mu sine 2 theta by 2, and we can write it cos 2 theta minus 1 by 2. We can write this, right? So which is 1 by 2 mu sine 2 theta plus cos 2 theta minus 1. Therefore, f prime theta is 1 by 2 mu cos 2 theta minus sine 2 theta into 2. That is 0. That means tan 2 theta is mu. Okay, so this is the condition for x to be maximum. Now, when mu is 1, that implies tan 2 theta is 1. That implies theta is 45 degree by 2, so which is 22.5 degree. Hence, D is the answer. Okay, quickly make the triangle. So we have 1, 1, root 2. So that implies that f theta is 1 by 2 sine 2 theta. So sine 2 theta is nothing but 1 by root 2 plus 1 by root 2 minus 1. So which is 1 by 2 root 2 minus 1. And then x max is L root 2 minus 1 by root 2 plus 1. From here, we know that this is the x, right? And that is equal to L root 2 minus 1 whole square, which is also L3 minus 2 root 2. And that gives me on somewhere close to 0.172 L. So that is the max x that will hang when theta is 22.5 degree for mu equal to 1. I hope you enjoyed this session and learned few things. Thank you for watching this video. And please don't forget to subscribe and like this video. We'll be posting another problem to help you out in preparation for JEE. Thank you. Subscribe and gain access to concepts and tips for doing better in IIT JEE or other examinations. Keep up the great work.